Hello viewers, welcome to today's section of food technology under which you will be studying about lipids. Let us start with the introduction. Lipids are a broad group of chemically diverse compounds that are soluble in organic solvents. Food lipids are generally referred to as fats or oils. Fats are solid at room temperature and oils are liquid at room temperature. The total lipid content and the lipid composition of foods can vary tremendously. Food lipids play an important role in food quality. They contribute to attributes such as texture, flavor, nutrition, caloric density. Some fats are essential such as linolenic and linoleic fatty acids. They cannot be synthesized by body. Therefore, they have to be met through diet. Fats and oils are insoluble in water and have a greasy feel that one may feel or can notice on a napkin or dinner plate. As a group of fats and oils should be used sparingly in the diet. Fats and oils are triglycerides, the major constituent of lipids. Overall, lipid is the umbrella term that includes the triglycerides, phospholipids and sterols. In this section, you will be going to study about structure of fat, classification of lipids, minor components of fats and oils and nomenclature of fatty acids. Let us start with the first one, structure of fat. The building block of fats are fatty acids and glycerol. A fatty acid is made up of a chain of carbon atoms with a methyl group at one end and the acid group at the other. As you can see in the screen that in the left side is the methyl group which is the CH3 and on the right side is the acid group which is COOH. Fatty acids occur primarily as unbranched hydrocarbon chains with an even number of carbons. The first one under structure is glycerides. Glycerides include monoglycerides, diglycerides and triglycerides. The most abundant fatty substance in food is the triglyceride which is around more than 95%. Triglycerides are insoluble in water and may be either liquid or solid at room temperature. Structurally, glycerides contain a glycerol molecule backbone joined to one or more fatty acid molecules. In the screen, you can see that a formation of monoglyceride in which there is a glycerol component which is attached to a fatty acid which forms monoglyceride. A monoglyceride contains glycerol esterified to one fatty acid molecule. If two fatty acids are esterified to glycerol, a diglyceride is formed. If three fatty acids undergoing the same reaction make a triglyceride. If a triglyceride contains three identical fatty acids, it is called a simple triglyceride. If it contains two or three different fatty acids, it is called a mixed triglyceride. Now let us study about the classification of lipids. Among the many compounds classified as lipids, only a small number are important as dietary energy sources. Based on the structure, the classification of lipids are simple lipids, compound lipids and derived lipids. The first one under classification is simple lipids. Simple lipids are esters of fatty acids with various alcohols. They are classified according to the nature of alcohols and the examples are fats and oils and waxes. Fats and oils are forms of lipids which are present in foods. They are esters of fatty acids and glycerol. At room temperature, oils are liquids and fats are solids. The next example is waxes. The chemical definition of a wax is an ester of a long chain acid and a long chain alcohol. Food waxes are a combination of chemical classes including wax esters, sterol esters, ketones, aldehydes, alcohols, hydrocarbons and sterols. Waxes can also be classified according to their origin as animal, plant and mineral. Waxes are found on the surface of plant and animal tissues. The second classification of lipids is the compound lipids. The compound lipids are esters of fatty acids containing groups of phosphorus, carbohydrate or protein. They are present in addition to an alcohol and fatty acid. The first example under compound lipids is phospholipids. Phospholipids are similar to triglycerides but contain only two fatty acids esterified to glycerol. In place of the third fatty acid, there is a phosphoric acid and a nitrogen containing group. The most common phospholipid is known as lecithin. You can see that a fatty acid is attached to a phosphorus group which is called as lecithin. Lecithin is found nearly in every living cell. The word is derived from the Greek lekithos, which means yolk of an egg, and lecithin is in egg yolk. The second example is glycolipids. Glycolipids contain a fatty acid, carbohydrate and a nitrogenous base. They have a carbohydrate component within their structure like phospholipids. They are generally not major components of food lipids. The third example is aminolipids and sulfolipids. The sulfolipids yield sulfuric acid on hydrolysis, similar to cerebrosides, except that sulfuric acid is present as cerebronic acid ester. They are generally not major components of food lipids. The last example is lipoproteins. Lipoproteins are macromolecular complex of lipids within proteins. These compounds are found in mammalian plasma bound with proteins. You can see a lipoprotein which contains cholesterol, triglycerides, phospholipid and protein. The lipid moiety consists of cholesterol esters and phospholipids. They contain stearic, palmitic, oleic, palmitoleic, linoleic and arachidonic acids. The last classification is derived lipids. Derived lipids are substances liberated during hydrolysis of simple and compound lipids. They retain the properties of lipids. Sterols, fatty acids and alcohol are the important members of derived lipids. Sterols are derivatives of steroids. They contain a common steroid nucleus, an 8 to 10 carbon side chain and an alcohol group. Based on their origin, sterols are classified as cholesterol and phytosterol. Cholesterol is the primary animal sterol. It is regularly synthesized by and stored in the liver. Cholesterol plays an important role in membrane function. Cholesterol is also important because it is the precursor for the synthesis of bile acids and 7-dehydrocholesterol. The most common plant sterols are stanols, are cytosterol and sigmasterol. Other plant sterols are found in margarine type products. The second classification is fatty acids. Fatty acids are long hydrocarbon chains with a methyl group at one end of the chain and the carboxylic group at the other. Most natural fatty acids contain from 2 to 21 carbon atoms and most contain an even number of carbon atoms in the chain. Fatty acids can be saturated or unsaturated depending on the degree of unsaturation. They are saturated fatty acids and unsaturated fatty acids. Among unsaturated fatty acids, it is monounsaturated fatty acids and polyunsaturated fatty acids. Now, let us see what is saturated fatty acids. If fatty acid has all the hydrogen atoms it can hold is said to be saturated. They have a linear shape and there are no double bonds between carbons. They contain only single carbon to carbon bonds and have the general formula CH3, CH2N, COOH. As you can see in the table, the saturated fatty acids are butyric, caproic which is present in butterfat, caprylic and capric which is present in coconut oil, lauric is present in coconut oil, palm kernel oil, myristic is present in butterfat, coconut oil and palmitic and stearic is present in cocoa butter and animal fat and peanut oil contains arachidic and behenic acid. The second example is unsaturated fatty acids. If some of the hydrogen atoms are missing and have been replaced by a double bond between carbon atoms, the fatty acid is said to be unsaturated. Generally, unsaturated fats are liquid at room temperature and the examples of unsaturated fatty acids are caprolic, lauroleic which is present in butterfat and some of the fish oils and beef fat contains palmitoleic and olive oil and canola oil contains oleic acid. Butterfat contains vicinic and linolenic is present in most of the vegetable oils, wheat germ oil, flaxseed oil and arachidonic acid is present in lard, meats and some fish oils. Under unsaturated fatty acids, the first one is monounsaturated fatty acids. If there is one double bond, the fatty acid is known as monounsaturated fatty acid. In table, you can see that different saturated fatty acids which contains different carbon atoms, and in saturated fatty acids there are no double bonds, whereas in unsaturated fatty acid, in caprolic, laurelaic, myristolic, palmitolic, oleic, vesinic acid contains single double bond and they are called as monounsaturated fatty acid. Linoleic contains 2 double bonds, linolenic contains 3 double bonds, arachidonic acid contains 4 double bonds and the carbon atoms present in this is 20, and erucic acid contains 1 double bond and the carbon atoms which is present is 22. Next is polyunsaturated fatty acid. If there is more than 1 double bond, then the fatty acid is known as a polyunsaturated fatty acid. In polyunsaturated fatty acids, the hydrogen atoms can be arranged in one of 2 ways. One arrangement is called cis, the other is called trans. They represent the different isomeric structures of the fatty acids. In the cis form, the hydrogen atoms are attached to the carbon atoms of the double bond. Hydrogen atoms are located on the same side of the double bond. In trans configuration of the isomer, the hydrogen atoms are located on the opposite sides of the double bond across from one another. As you can see in the screen, in cis bond, hydrogen atoms is arranged on the same side, and in trans form, the hydrogen is present on the opposite sides of the chain. The configuration of the double bonds affects shape of a fatty acid molecule. Trans configuration do not significantly change the linear shape of the molecule. However, a cis double bond causes a bend in the chain. All naturally occurring fats and oils that are used in food exist in the cis configuration. Hydrogenation of oil causes conversion of double bonds to the trans configuration. With this property, some trans fats may be used in food. Next is essential fatty acids. The body cannot make all the fatty acids it needs except for 2, known as alpha linolenic acid and alpha linoleic acid. These are called as essential fatty acids and must be supplied in the diet. From these fatty acids, we can make others which are important for health. From linoleic acid, we can make arachidonic acid, and from alpha linolenic acid, we can make eicosapentaenoic acid and docosahexaenoic acid. The eicosapentaenoic acid and the docosahexaenoic acid can also be obtained from oily fish and fish oil supplements. The omega-3 fatty acids, particularly alpha linolenic acid, are present in the meat or eggs of animals fed with omega-3 enriched diets. Foods produced in this way could be considered alternative sources of oily fish, although the amounts of long chain omega-3 fatty acids present may be considerably less. Next is minor components in fats and oils. Tocopherols are important minor constituents of most vegetable oils. Animal fats contain little or no tocopherols. Tocopherols are antioxidants helping in prevent oxidative rancidity. They are good sources of vitamin E. They are partially removed by the heat of processing. They may be added after processing to improve oxidative stability of oils. If vitamin E is added to oil, the oil frequently is marketed as a source of vitamin E or as an antioxidant containing oil. Fats are not good source of vitamins apart from vitamin E. In order to increase the nutritive value, fat soluble vitamins like vitamin A and vitamin D may be added to foods such as margarine and milk. Pigments such as carotenoids and chlorophylls may be present in fats, and these may impart a distinct color to fat. Next is isomerism. Fatty acids may have geometric or positional isomers which are similar in number of carbon, hydrogen and oxygen, but form different arrangements. Therefore, they offer different chemical and physical properties. Oleic and L-acidic acids are examples of geometric isomers existing in cis and trans forms respectively. Next is nomenclature of fatty acids. Fatty acids are named in three ways. It is common name or systematic or Geneva name, and then the omega system. Common or trivial name is the name which has been used for many years. Systematic or Geneva name, which is more recent and has the advantage of describing the structure of fatty acid to which it belongs. And the third one, the omega system, classifies fatty acids according to the position of the first double bond, counting from the methyl end of the molecule. Fatty acids also are denoted by two numbers. The first signifies the number of carbon atoms in the chain, and the second indicates the number of double bonds present. For example, oleic acid, which contains 18 carbon atoms and one double bond, could be written as 18:1. Now let us see how Geneva or systematic nomenclature is being done. The Geneva naming system is a systematic method of naming the fatty acids. Each name completely describes the structure of fatty acid to which it belongs. Each unsaturated fatty acid is named according to the number of carbon atoms in the chain. As you can see in the table, stearic acid, which has 18 carbon atoms in its chain, has the name octadecanoic acid. Octadec means 18. The oic ending signifies that there is an acid group present. Anoic signifies that there are no double bonds in the chain. Palmitic acid, which contains 16 carbon atoms, is named hexadecanoic acid. Hexadec means 16, and the anoic ending again shows that there are no double bonds in the fatty acid chain. Fatty acids containing double bonds are named according to the number of carbon atoms they contain. Therefore, oleic acid, linoleic acid and linolenic acid all have octadec as part of their name, signifying that they each contain 18 carbon atoms. The rest of the name differs because they contain 1, 2 or 3 double bonds. The number of double bonds and their positions in the fatty acid chain are both specified in the name. It is important to note that position of double bond is specified counting from the functional or acid end of the molecule, not from the methyl end. Oleic acid has the name 9-octadecanoic acid. The number 9 refers to the position of the double bond between carbon 9 and carbon 10, counting from the acid end. The name ends with enoic. The N signifies that there is a double bond present. The second example is linoleic acid. Linoleic acid is named as 9,12-octadecadienoic acid. The position of double bonds is counted from the acid end. Octadeca means that there are 18 carbon atoms in the chain, and diene signifies that there are 2 double bonds in the chain. The third example is linolenic acid, which contains 3 double bonds. It is named as 9,12,15-octadecatrienoic acid. The letter triene indicate that there are 3 double bonds in the chain. The configuration of the double bonds may also be specified in the name. For example, oleic acid and elydic acid are geometric isomers. The double bond in oleic acid exists in the cis configuration. Elydic acid contains a double bond in the trans configuration. The complete name for oleic is cis 9-octadecanoic acid, and elacidic acid is named as trans 9-octadecanoic acid. By looking at a systematic name for a fatty acid, it is possible to tell how many carbon atoms it contains and how many double bonds and where they are located. Each name gives important information about the fatty acid that it is not available just by looking at the trivial or the omega name of the acid. The last one is the omega naming system. The omega naming system is used for unsaturated fatty acids. It denotes the position of the first double bond in the molecule counting from the methyl end, not from the acid end, as we have studied in the Geneva system. This is because the body lengthens fatty acid chains by adding carbons at the acid end of the chain. Using the omega system, a family of fatty acids can be developed that can be made from each other in the body. For example, an omega 6 fatty acid contains its first double bond between carbon 6 and carbon 7, counting from the methyl end. Linoleic acid is an example of an omega 6 fatty acid, and it is the primary member of the omega 6 family. Given linoleic acid, the body can add 2 carbon atoms to make arachidonic acid, which also is an omega fatty acid. The primary omega 3 fatty acid is linolenic acid, which contains 3 double bonds. The first double bond is between carbon 3 counting from the methyl end. The body can synthesize both eicosapentaenoic acid and docosahexaenoic acid from linolenic acid. Both eicosapentaenoic acid and docosahexaenoic acid are omega 3 fatty acids because their first double bond is located at carbon 3, which is again counted from the methyl end of the molecule. Let us conclude this session. Food lipids play an important role in food quality. They contribute to attributes such as texture, flavor, nutrition and caloric density. A fatty acid is made up of a chain of carbon atoms with a methyl group at one end and an acid group at the other. Lipids are classified as simple lipids, compound lipids and derived lipids. Based on the degree of saturation, fatty acids can be classified into saturated fatty acids and unsaturated fatty acids. Essential fatty acids like alpha linolenic acid and linoleic acid cannot be synthesized in the body. Therefore, they must be supplied through the diet. Minor components of fats and oils includes tocopherols and pigments. Fatty acid chains of even number may exist as geometric or positional isomers. Nomenclature may be according to a common name, systemic or Geneva name or omega system. Thank you.